Hi, my name is Juan Pablo Alvarez Sáenz. I am a student of Mechanical Engineer of the University of America. Now I will explain you our final work based in thermal machines. Okay, our study case is a thermoelectric plant that operates in the ideal Rankine cycle with reheat, with pressure limits in 25 megapascals and 10 kilopascals, with a maximum temperature of the cycle of 600 centigrades and a moisture content of 8% at the turbine outlet. The principal need in our study case is to find the pressures of reheat in single and double with the temperature of 600 centigrades. For solving our problem, we need to take some assumptions. So the first is that efficiency of the components in the cycle is constant. We need to know all the information in the state 6 to find the pressure of single reheat, and kinetic and potential energy change are negligible because our cycle is ideal. For the analysis of the first item in our study case, we need to use our diagram, temperature versus entropy of our cycle. So in this diagram we will see the maximum temperature of the cycle, that is 600 centigrades here, and we can watch the two pressures known, that are 25 megapascals and 10 kilopascals. Okay, we need to find the pressure that is in the state 5 here, that is the same in the state 4. But why is important to make this diagram? This diagram helps us to know which point has the same temperature or the same pressure or the same entropy. So with this information we can enter to the tables so easy, and that's why we need to make this diagram first and then make the mathematical development. So in our development we know that the moisture content is 8%, and with that information we can know that the mix quality is 92%. For finding the enthalpy and the entropy, we will make the same development, that is, finding our property of the fluid, the enthalpy of the fluid or the entropy of the fluid, and we add the product of the quality and the entropy or the enthalpy of the steam and water mixture. With that procedure we will find the property in the state 6. Making this process, we find that the entropy in the state 6 was 7.54 kilojoules per kilogram Kelvin, and with that information we will know the state 6, and then we will begin the analysis of the state 5. Okay, now we know the state 6, and with that information we will know the entropy in the state 5. Then we will enter to the steam tables and find two values of entropy that are one bigger and one smaller of our entropy, and in that point we will know the pressure of the state 5. Here we can look how we find that value. We make an interpolation in the pressures of 2.5 and 3 megapascals. With that interpolation, we obtain that our pressure of single reheat is 2.78 megapascals. That information is obtained of the table A6 of the steam tables. Thank you. Now, for the second part of the analysis of our study case, we need to know that the pressure of the double reheat is between the maximum pressure of our cycle and the one we found previously. That was of 2.78 megapascals, because the quality of the steam in that point continue being the same. So every pressure between these two pressures that we are taking into account will satisfy the pressure needed in the reheat in that point. The last part of my presentation are the conclusions. Okay, the first is double reheat is only used in cycles which the maximum pressure are supercritical, that are bigger than 20 megapascals. Okay, the second is that the principal purpose of the reheat cycle is to reduce the steam content in the final states of the cycle. That makes the efficiency bigger in our cycle. And the final is that optimum pressure of reheat is near the maximum pressure of the cycle. One example, if the maximum pressure are 15 megapascals, the reheat pressure will be like 3 megapascals. Finally, I have to make an special apart for my teacher, Claudio Alberto Moreno. I enjoy a lot this signature, and I give my congrats to his job teaching this beautiful science of the therm machines. Thanks.